We're right now on the Tech Talk, which is permissionless blockchains for enterprise. And we've got with us Matthew, co-founder and president, Aleph Zero. Well, Matthew is somebody who's earned a PhD in mathematics in the field of numerical algebraic geometry from Colorado State University. A Simmons Berkeley Fellow and also an IBM Center of Excellence Fellow in High Performance Computing at Oak Ridge National Laboratory. Has been active in the DLT space since 2014 and has provided consultation related to security and consensus models, cryptographic schemes, as well as applying sound business and technological models to numerous projects. So thank you so much, Matthew, for joining us today online, and welcome to the World Blockchain Summit.
Thank you for having me. So bear with me. It's quite early for myself here. I'm on the East Coast in the U.S., but this is actually a phenomenal conference that you guys have put together. I'm very happy to be here. So I'll be just kind of going over why are we really interested in these permissionless blockchains and what does that really offer, from an enterprise perspective. So for the most part, we've hashed out, to death this whole notion of, what are the applications of enterprise. Just in the last panel, we were talking about, what happens, and what you really need at the end of the day is just some value provided to you, whether this is in cost savings, whether it's making your life easier, maybe it's just better efficiency, and so on. So what you have to start thinking about is what's the fundamental difference between these permission platforms and these permissionless platforms. And at the end of the day, it becomes this notion of censorship resistance. So now we need to start understanding what are some of the challenges of having an enterprise application on these permissionless blockchains. And really the one of the biggest things that we have to start thinking about is how can we handle the level of privacy that we expect from a consortium platform or from basically a single server database, and how this really translates into this blockchain setting where we have multiple parties who are participating in securing the network, who may have access to the data. For whatever reason, we may want to restrict certain access for writing the data or for querying it and for reading it. So what you really need to start doing in this setting is to apply this notion of role-based access control using a public key infrastructure to go ahead and restrict the rights associated to a particular public key, as far as whether or not they're allowed to read particular data, to download some information, or whether or not they have the authority to write to the database. So this can really be achieved sort of automatically in the permissionless setting just by defining what the public key infrastructure should be. As far as some of the other challenges that we have, you might want to be able to enable this notion of private smart contracts. And this is actually quite a hot topic, not just in the blockchain space, but in the mathematical world for quite some time. So there's this notion of multi-party computations. And multi-party computations allow you to perform these types of computations in a way where you can withhold certain information from at least as a starting point, but then get a publicly verifiable output. So what you could do potentially is calculations like, well, I could just add two numbers together. I could, multiply two numbers together, and I do so in a distributed fashion. And now I can do private machine learning applications. So for instance, two companies could go ahead and, or even not just two, just some multitude of companies could share their data in such a way where they could do some machine learning application on it without necessarily providing the raw data to either of the other parties who are doing this computation. And this really unlocks the ability of, this data that had been siloed off before and was, just sort of sitting there, unused, untapped. And now with these new techniques that have been developed over the course of the last 3 decades, 4 decades or so, really started off with Andrew Yao from who's currently at Tsinghua University. He solved this notion of the millionaires problem, which really kicked off this entire field of multi-party computation. But what you can do with this is some really phenomenal, the applications are really just endless, and we really have yet to understand all the potential that exists behind them. But one of the several applications are things like private set intersection, and the idea behind this one is that, say you're having some type of merger and acquisition, and this merger and acquisition between two entities, they have some way of defining the standardization for their data, and now they can go ahead and do this, what's called the set intersection, to see how much data that they have that they may that might be valuable to both companies. How much of this is actually the same information? So it could be the case that the valuation of the of either entity and what either party is willing to pay during this merger goes up or down, dependent on how much shared or overlap data there exists between the two. So that could also be done without revealing the information as to what's the underlying raw data is. And so then only after you perform this calculation, or after the merger has been approved, or some other due diligence checks have been passed, you can go ahead and open that kind of hidden data. So really, there's all sorts of applications. Another one, as I was saying, is this whole notion of private smart contracts. So all of your general or calculations and computations can be offloaded and sort of moved into this multi-computation setting. But beyond that, you still have to deal with this notion that public platforms are notoriously slow, right? Or they're not as fast as you can achieve with your classical permissioned database or permissioned blockchain setting. And you have to start thinking about, well, what's this really mean? Why are there certain aspects or certain properties that are more achievable than others? And when you start digging into the details of the mathematics, and you don't have to really worry about what's going on in the mathematics. We let the mathematicians and the research scientists really understand and handle all these, all the actual the situations that are occurring there. You start to realize that this has really been thought about for the last 4 decades. And how do we actually go ahead and change this paradigm from moving from a permission setting to a permissionless setting? Well, we really just go ahead and throw in some type of anti-Sybil mechanism up front, as far as choosing some small set of validators that will run a permissioned protocol for a small moment of time, and then move on to the next set of committee members who will operate this classical permission protocol. And this is the design that everybody's doing. This is how Cosmos operates. This is how Algorand operates. This is how you just look out there. It's this whole notion of, well, I'm going to randomly select a small committee or a large committee, doesn't really matter, from a larger pool of potential validators, and then they're going to just run this permission protocol for a small moment of time. And this is starting to get into this whole notion of trying to solve the trilemma, where you need to be able to have high throughput, being able to handle a lot of transaction load, to be fast to finality. So you need to have a small number of for your confirmation time, and then also being able to handle the more nodes who are participating directly in the protocol itself is how scalable you are. But the big issue is that you often have to, in order to achieve either of those two properties, you will sometimes go ahead and sacrifice security, and this is the so-called blockchain trilemma. So what we've been able to do with Aleph, for instance, is to go ahead and start from the first principles, where we focus directly more on the science and the research, and then build out our applications from there. So to that end, we've been able to design our consensus protocol in a very modular way. And this modularity, what this allows us to do is reach agreement solely on the order of bytes, because bytes is just your most general way of ordering, say a transaction, because a transaction ID is just a sequence of bytes. And if we can just go ahead and abstract this notion of what we're having agreement on as far as the underlying data, well, it's just agreeing on what's the order of, or rather agreeing on what the bytes actually are. And what we can then do is really offer a universal sidechain solution, or even a universal interoperability solution for any smart contract system out there. So with very little work, you can go ahead and plug and play our consensus module and use anybody else's smart contract system and deploy it on our platform. And that's sort of one of the advantages that you have with this design. And the other aspects that you got to start thinking about is how do you handle this interoperability between multiple platforms. So this is really about identifying who has the ownership of a particular data, who has the ownership of a smart contract, which platform is this associated with. Can we go ahead and track how this ownership moves through these interoperable networks? And for the most part, we have these problems are solved. That's really the question never becomes what can we do with this technology. It's more like, what do you want to build? Because this has been out there for quite some time. You're looking at over 4 decades of distributed systems research has been going into the space. And really with any blockchain platform at its core, you just have a consensus protocol, you have a way of manipulating the underlying database, and you just have to start dealing with how do you handle multiple parties who are participating in these networks. And the public and permissionless blockchain space has really solved most of these issues. And what we really need to do at the end is go ahead and figure out how to maintain privacy, and that can be done with the multi-party computation, and all these applications that come from that. So it's really no longer something that we need to focus on as far as having consortium chains or having a permissioned platform, and people can just go off to the side and be siloed away from the rest of the ecosystem. What we can do is bring people together and offer a sort of a public platform for everybody to go ahead and interact with and to use as a primary communication layer. And that's what we're trying to do. We want to have the network effect. We want to be able to engage people. We want to have basically people build whatever it is that they want, and we're here to help. We're here to really focus on the privacy aspects. How can we build what we want and be safe and secure all at the same time? So with that, I'll go ahead and hand it back over. Thanks.
Thank you so much for that.